Jai Hind everyone, I am Dr. Smrati Tripathi from Applied Science and Humanities Department, Ajay Kumar Garg Engineering College, and today's video lecture is for Mathematics 4 which comes under code KAS 302 or 402, and today we are discussing Statistical Techniques 3. In these statistical techniques, we are discussing control charts for attributes. Before proceeding that what are these control charts and why we go for this for attributes, I'll show you a chart. Now here I have written types of control charts. So control chart we choose on the given data. If the data is given to us continuous, then we use variable charts, and if the data is given discrete, then we use attributes chart. If the data is continuous, then we use chart R chart, which is also called range chart, and X bar chart, which is called mean chart. And if the data is given discrete numerical data, then we use attribute charts, and in that comes P chart, NP chart and C chart. So today we are going to discuss P chart, which we use for fraction defectives, and then we will discuss NP chart, which we use for when the number of defectives are given to us, and then we will discuss C chart for n defects per unit. Let us understand what is P chart. The P chart is constructed for controlling the quality standard in the average fraction defective of the products in a process when the observed sample items are classified into defectives and non-defectives. So what do? We calculate in this control limit, upper control limit and lower control limit, and then we draw a chart. If our digits comes within the limits, means our values, the given values are inside the upper control limit and lower control limit, then the process is under control, otherwise process is not under control. Now the question arises, what are these control limits? So let us see the control limits for P chart. Here the upper control limit, which is P bar plus Z under root P bar into 1 minus P bar upon N. Now the question arises, what is Z here? So if we are, or if the process we are standardized, or we are looking for the quality control when Z is equal to 2, it means when we are taking the level of significance 95.5%, then we take Z is equal to 2, and when we take level of significance 99.7, then we take Z is equal to 3. And similarly, the lower control limit will become P bar minus Z into under root P bar into 1 minus P bar upon N bar. Now what is N bar here? N bar is the number total sum of the samples where summation I is equal to 1 to k Ni, means the defective items in sample I divided by k, total number of defective items, and P bar is the summation I from 1 to k xi upon summation I is equal to 1 to k Ni. So where xi is the defective items in the sample and Ni is the size of the sample. Now here sigma P bar is equal to, as we know, the upper control limit. Upper control limit is always mean plus standard deviation, and lower control limit is always mean minus standard deviation. So what is under root p bar into 1 minus p bar upon n, which is sigma p bar, means standard deviation for p bar, where n is the size of each sample. So this is the formula for the p chart control limits. Let us take a question and try to understand that how we will calculate these control limits, and then how we will draw the charts, or how we will get to know that whether the process is in control or not. Here we have a question, and in this question there is a manufacturing process. The number of defectives found in the inspection of 20 lots of 100 samples. It means in lot number 1 there are 100 samples being examined, and out of which 5 samples are defective, and similarly for 2, 3, 4, 5 up to 20, and in the 20th lot also there are 100 samples, out of which 4 are defective samples. Now what we have to find? It should be here determined. So determine the control limits of P chart and state whether the process is in control or not. So first of all, we will find the control limits of P chart. We know that the control limits of P chart are UCL and LCL, both depends on P bar. What is P bar here? P bar is the total number of defectives upon total number of items inspected. So now you see here how many items are defective. So we will add all this 5, 4, 3, 5, 4, 6, 9, 15, 11, 6 and so on, and we will get 120. So the total number of defective items out of 20 lots are 120, and the total number of items inspected, that is, in each lot there are 100 items being inspected, so it means 20 into 100. So when we solve it, we will get P bar is equal to 0.06. Based on this P bar, we will find upper control limit and lower control limit by the given formula. In general, when Z is not mentioned in the question, then we take Z is equal to 3. It means upper control limit is equal to P bar plus 3 under root P bar into 1 minus P bar upon N, where P bar is 0.06 plus 3 under root P bar is 0.06 into 1 minus 0.06 upon 100, which will give us value 0.13095, and lower control limit will become P bar minus 3 under root P bar into 1 minus P bar upon N, and we will get the value 0.01095. As we have already understood that the control charts, in that control charts, LCL and UCL, here it should be negative. The value will come which will be negative. When we calculate, the value will be minus 0.01095. So the value is coming negative, and we know that whenever the value is in negative, then we take lower control limit as equal to 0. We cannot take control limit as negative value, so we take it as equal to 0. So LCL will be 0. Okay, because fraction defective cannot be negative, so lower control limit also cannot be defective because the value here is coming in negative. So now we will again see our sample. Now observe these samples. We have the values which means our lower control limit is 0 and upper control limit is 0.13. Okay, so it means the fraction defectives must lie between 0 to 13, because we are, so we can say this is 13 upon 100, because out of 100 samples 13 are defective. So upper control limit says if out of 100 samples, 13 are defective, more than 13 are defective, then the process is not in control. That's what the meaning of lower control limit and upper control limit. If the number of defectives cannot be less negative, so we cannot take it in negative. So that is why we are taking LCL is 0 and upper control limit. If the number of defectives are more than 13, we cannot take it it is the considerable fraction defective. So we cannot take it. Now we will observe the given values. Now 5 are defective in this one. 5 are defective out of 100. So that is 0.05. And what we have decided in this? We have decided that if out of 100, more than 13 are defective, we will exclude that. So now you see here out of 100, 5 are defective, 4 are defective, 3, 5, 4. And when we examine, we can find the 15 is here. Now this 15 is greater than 13. It means for this particular value, the process is not under control, and that's what is being asked. State whether the process is in control or not. So we can say that after observing the values of defectives in the given example, it is clear that only 8th lot having fraction defective, that is 0.15, it means out of 100 samples, 15 are defective, so which will go above upper control limits. So we cannot consider it, and hence the process at this position is not under control. So this was about P chart. Now let us discuss NP chart. What are the control limits of NP chart? And when to use this NP chart? Whenever subgroup size is variable, P chart is used, but whenever it is constant, then we use NP chart. Then in that case, control limit becomes NP bar, where P bar becomes summation NP upon summation N, and upper control limit, once again it will be, because as I told you always that upper control limit is always control limit plus 3 into standard deviation. So what is the, it will be control limit is what? NP bar, and upper control limit will become NP bar plus 3 under root NP bar into 1 minus P bar, and lower control limit will become NP bar minus 3 into under root NP bar into 1 minus P bar. Now let us understand one example based on this. Now the question here which we have is, in a blade manufacturing factory, 1000 blades are examined daily. Draw the NP chart for the following table and examine whether the process is under control or not. Now here dates are given, like from date 1 to date 15, the 1000 blades are examined on the daily basis, and out of 1000, 9 blades are defective, and in the second day out of 1000, 10 blades are defective, and so on. And 15th date, out of 1000, 16 blades are defective. So here N is 1000, and total number of defectives are 166. The total number of defectives are 160, and total number of blades which are inspected are, how many days these are being inspected? 15 days, because from day 1 to day 15. So 15 days into, and every day how many blades are being examined? 1000. So 1000 into 15 becomes 15,000. So what will be P bar? As we know, P bar is summation NP bar upon summation N. So that will be 166 upon 1000 into 15, and that will give us value 0.011. Now this is P bar only. What do we want? We want NP bar. So NP bar will become 1000 into 0.011, which is equal to 11. Now, what are the control limits? The control limits are, first control limit will be NP bar, which is 11. Upper control limit will be, I'll apply the formula for NP bar. So, it will be 11 plus 3 under root 11 into 1 minus 0.011, which will give us value 20.894, and lower control limit is 1.106. So, the first part is done, that we have calculated the control limits. Now, it comes to draw the NP chart and examine. Like in the previous question, it was only said that examine whether the process is in control or not. But in this question, they are saying draw the NP chart and then find whether the process is in control or not. We have drawn here. Always remember that whenever we draw a control chart, sample numbers always come in x-axis. Like horizontal part is always sample for the sample number, and vertical axis is always for the number of defective blades. Okay. So now here how many samples we are having, or sample numbers we are having? 15, because we have examined blades from 1 to 15 date. So this is 1, 3, 5 I have taken. Now on first day, before taking that what was the sample on day 1 or day 15, we will draw control limit, upper control limit and lower control limit. As we can see that here the number of defectives are 9, 10, 12 and up to so on 16. So we have drawn the graph in the same way, like 0 to 5, 10, 15, 20 and 25. And the lower control limit is always a dotted line at 1.106. So we have drawn a dotted line and drawn the lower control limit. And similarly, the value of upper control limit is 20.894, and we have drawn 20.894 on y-axis and drawn a dotted line parallel to horizontal axis. And similarly, control limit, which was having value, the control limit was having value 11. So we have drawn a full line at 11 on the y-axis parallel to x-axis. So this is control limit, which is equal to 11. After drawing these upper control limit and lower control limit, we will draw the number of defectives on daily basis. So on day 1, the number of defectives were 9. So we will mark here at 9. Similarly, on day 2, see here day 2, the number of defectives were 10. So we have marked here at 10. On day 3, see here it is 12. So we will take here 12. And so on day 15, it was nearly 16. So we have marked on 15th day, the value was, the number of defectives were 16. So we have taken here at 16. So we have marked all the number of defectives on the given dates. And then we will join these marks by straight lines. We have done the same way. We have joined each mark by the straight line and we have got a control chart in this way. Now we can see that whatever the figure is being drawn, whatever the chart, all the limits are within lower control limit and upper control limit. What does it indicate? I told you already that whenever any number of defective items goes beyond upper control limit or lower control limit, then the process is not under control. But if all the defective items comes within the control limits, then the process is under control. So hence what we can see in this question? In this question we can say that the process is under control. So this was all about NP chart. I'll discuss one more question on the NP chart. Now in this question it was given, if the average fraction defective of a large sample of a product is 0.1537. Already the average fraction defective is given. So it means P bar is already given to us. Now they are saying calculate the control limits given that subgroup size is 2000. Now I told you whenever the subgroup size is constant, then we always use NP chart. That is why, see, in the question it is not mentioned that you have to find the control limits of which chart. But because the subgroup size is 2000 which is given and it is a constant value, hence we will find the control limits of NP chart. And in that, average fraction defective is always already given to us. Subgroup size, which is n is equal to 2000, is already given to us. So we will apply the formula of control limits, which is CL is equal to, CL means control limit is equal to NP bar. So this will give us 2000 into 0.1537 and this will give us the value 307.4. And the upper control limit will become NP bar plus 3 sigma, and again I will put the values here. So we will get 355.78772. And the lower control limit similarly we will get on putting the values of NP bar and 1 minus P bar, we will get 259.012258. I hope you understood very well NP chart. Please solve questions and check whether you are able to solve it or not. So we have discussed till now P chart, NP chart, and now we have to discuss C chart. When to use C chart? As I have already told you in the first slide that C chart is for defects per unit. Let us say we have a cloth, glass or paper, so which may contain more than one defect. So whenever there is more than one defect, then we always use C chart. For C chart, we apply Poisson distribution, and we know that in Poisson distribution, mean and variance are always same. Now let us see what are the control limits for C chart. So the control limits for C chart are, so first is, this is the control limit which is called C bar, which is the number of defects, total number of defects in unit I. What is CI? I is the number of defects in a particular unit, and K is that how many units are being examined. So what is C bar? The total number of defects upon the units sampled. So this gives us the value of C bar, which we consider in C chart as control limit. Now what will be the upper control limit? We know that the upper control limit is always C bar plus 3 under root C bar. And the lower control limit will be C bar minus 3 under root C bar, which is mean plus 3 into standard deviation and mean minus 3 into standard deviation. I told you that in C chart we are using Poisson distribution, and in Poisson distribution mean and variance is always same. So if C bar is the mean, then C bar is the variance also, hence the standard deviation will be under root C bar. So that is why we get this formula C bar plus 3 under root C bar, and lower control limit will be C bar minus 3 under root C bar. Let us discuss a question and understand how to draw the C chart and how to find the control limits. we have a question here that number of weekly customer complaints are monitored in a large hotel. So they are saying that develop 3 sigma control limits and then check whether the process is in control or not. Here we have to check the process is in control. We will check this also. So what is CL? CL is the number of complaints or the number of defects in one day and total number of samples. So number of defects in one day plus, because I have told you we are taking summation of all defects. So this will be the total number of complaints upon total number of samples. So the total number of complaints are 3 to 5, 3, 8 and so on. We are getting 22. And the total number of samples are here 1 to 10. So the total number of samples are 10. So the control limit is 2.2. Hence the upper control limit will become. So they have written 3 sigma control limit. This means Z is equal to 3. I have already always told you that this value can be written as C bar plus Z under root C bar also and C bar minus Z under root C bar also. What is Z? If Z is given to us, then we adopt the value of Z which is given to us. But if this Z is not given to us, then we usually take it as equal to 3. For the given question, they have already told us that take 3 sigma control limits. It means the value of Z here is equal to 3. So we have taken C bar. So here for LCL we have taken C bar plus 3 under root C bar, and which gives us the value 6.65. And the lower control limit value will be minus 2.25, which is equal to 0. Why? Because we cannot take lower control limit as negative. So we always take it as equal to 0. Now let us see how to draw its chart. So as I told you, we always draw the sample size on the horizontal axis. So now let us draw a horizontal axis. When we draw a horizontal axis, we can say that this is 0 and this is day 1, day 2, day 3, 4, 5, 6, 7, 8, 9 and 10. And here it is the number of defects. Number of defects. So the defects are given to us as 1, 2, 3. So we will draw it as 1, 2 and 3. So the number of defects comes within 1, 2 and 3. Now we will draw the control limits. So what are the values of the control limit? The lower control limit is 0 itself. So let us draw lower control limit at horizontal axis itself. So this is the value of LCL, which is equal to 0. The control limit is given to us 2.2. So if this is 2, if this is 2, this is 2.1 and this is 2.2. So we will draw the control limit, and the control limit is equal to 2.2, and the upper control limit value is 6.65. Now we will draw the 6.65. So 1, 2, 3, 4, 5 and it will go even beyond this 6. And even after that, so 6.65 will be somewhere here. So we will draw a dotted line here. So the upper control limit is equal to 6.65. Now we will draw all the defects, or you can say mark all the defects. On the first day, the defects are 3, means the number of complaints are 3. So we will mark here 3. On second day, it's 2. So it's 2. On second day, it is 2. On third day, it is 3. So on third day, again, it is 3. On fourth day, it is 1. So on fourth day, it is here 1. On 5th day it is given 3, on 5th day it is given 3, again on 6th day it is given 6, on 7th it is 2, on 7th day it is 2, on 8th day it is 1, so it is somewhere here 1, on 9th day it is 3, so on 9th day it is somewhere here 3, and on 10th day it is given 1, so on 10th day again it is here somewhere 1. Now we will join all the marks by straight lines, bold straight lines. So we will start from sample number 1. So we will join these two from here to here. Then it comes to this point. So 3 we have joined, then goes to 4, then it goes to, so then it goes to 5 here, then it goes to 6 here, and then it goes to 7 here. I think I have missed somewhere 7. 7 is 2. 7 is 2 I have drawn, 6 is 3, 5 is 3, and 4 is 1. 4 is 1. I have left 4 here. So 4 is here somewhere. So this will be somehow, it will be like this. We will just draw the some points once again, because I have missed one point. So this is 3, and at 4 it is 1, at 4 it is given 1, and at 5 it is given to us 3, at 6 it is again given to us 3, and at 7 it is given to us 2. So at 7 it is 2, and then at 8 it is given to us 1. So here again 1, and at 9 it is given to us 3. So again here 3. So now we will join all the marks here. So it will come here and then go here up, then this point, and then it will come down here, and then it will go here and again here. So we have got this kind of chart here. You can see very carefully that all the points are within the lower control limit and upper control limit. None of the point is going beyond the control limits. Hence, the process is under control. So this was all about P chart, NP chart, and C chart. Thank you so very much.